In this video, we'll be looking at an example of how to solve a quadratic equation by completing the square. Ava is throwing the ball up in the air from a starting height of 6 feet with an initial upward velocity of 32 feet per second. This situation can be represented by the equation h equals negative 16t squared plus 32t plus 6, where h represents the height of the ball above the ground in feet, and t represents how long the ball has been in the air in seconds. Let's use the equation to determine when the ball will hit the ground. Well, the height of the ball when it hits the ground is 0, so we can set h to 0. To find the value of t, we will be completing the square. The first step would be to get the coefficient in front of t squared to equal 1. So we need to divide each side of the equation by negative 16. That would leave us with 0 is equal to t squared minus 2t minus 3/8. Now we're going to add 3/8 to both sides of the equation. We don't want that on our side with the square. So I get 3/8 is equal to t squared minus 2t. Now we need to add the number that would complete the square. Remember that was 1/2 b quantity squared. Well, 1/2 of negative 2 is negative 1, and when we square that, we get 1. So we'll add 1 to both sides of the equation, giving us 1 3/8 is equal to t squared minus 2t plus 1. When we factor that, we get 1 3/8 is equal to t minus 1 times t minus 1. Now we'll take the square root of each side. The square root of 1 3/8 is approximately 1.17. And then, of course, the square root of t minus 1 squared is t minus 1. Again, we're going to solve both situations. We have t minus 1 is equal to positive 1.17. And t minus 1 is equal to negative 1.17. When we solve those, we get the time would be equal to 2 1700ths and negative 1700ths. What do those numbers mean? Well, the 2 1700 seconds represents how long it'll take for the ball to land on the ground. Remember, the ball was thrown at a starting height of 6 feet. If we were to continue the parabola behind the thrower's hands, it would intersect the x-axis at negative 1700ths of a second.